Hi, my name is Johanna Stewart, and this is my video on the first lab of physics 2212. So first of all, the purpose of this lab was to observe and analyze the behavior of the tape and to determine its charge. A preview of the results is that our tape is going to be charged with a charge of negative 7.83 nanocoulombs approximately. And some key assumptions that I wanted to mention are that we're going to assume that there's not going to be any air resistance, and also that to get the mass of the tape, we're going to be dividing the length of tape in centimeters by grams per meter. Also, in order to charge the tapes, the process we used was a triboelectric charge, in where we stuck two tapes together, and then by ripping off the top one, it would rip off some electrons. Some fundamental principles are, first of all, Coulomb's law, that explains the forces that interact between two charged objects, whether they have like charges or different charges. They're going to be attracted and repelled respectively, and also the electric field. And I'm showing the formulas for both of these theorems. An overview of the system of the experiment is that we're going to have a tape we're going to call B laying on top of two columns, and then when we approach the tape A, the tape B is going to be floating as shown in the second picture. Some additional assumptions are going to be that we're going to assume that the charge is located at the center mass of the tapes, and that the charge remains constant, and also that both tape A and tape B have the same charge. The system is going to be tape B, while the surroundings are tape A and the Earth, since these are both working on our system. And the initial conditions are that the tape B is going to be 25 centimeters long, and tape B is going to have a mass of 0.25 grams. So, the results of our experiment here, and we can conclude that when the tape is floating, the tapes A and B are 0.015 meters apart, and when the tape B floats, it remains at a fixed position, and thus the net force is going to be 0. So we can do a calculation and isolate Q, and thus get the charge, which resulted to be negative 7.83 nanocoulombs. And we can find out how many electrons were transferred into our tapes by dividing this amount by the charge of an electron, and finally we get that that there are about 4.89 times 10 to the 10 electrons in our tape. What fraction of atoms give up electrons? So we did a research and concluded that the tape is mostly made of a material called polyacrylate, and thus by calculating the smaller mass, we were able to get the number of atoms that were made up the tape, which was approximately 1.75 times 10 to the 21 atoms. And then by dividing this over the number of electrons, we got a ratio that could tell us how many atoms there were per released electron. So this is the computational model I built. Here I defined the charges, the separation, and then could create a visual representation that could also output the charge of the tape pieces. And some assumptions that I also took for this were that I could ignore the air resistance on the moving object, and that the long tape was treated as, and both tapes were treated as a point charge. Comparing some of the results, so when I did this experiment experimentally and computationally, both charges were accurately calculated using the theoretical principles, and they were both treated as little point charges in both types of experiments. However, the results of the computational model I feel like were more precise because I used fewer approximations than when I did it manually. Some possible sources of errors were that in reality the charge is not going to be concentrated in the center. It's going to be distributed along the tape. Also, the tapes may have different charges because of the number of electrons ripped out during the triboelectric charging, and also some of the charge could have been dissipated or lost into the surroundings or us while manipulating them. Further questions. What does it mean? So to answer the first question, if electrons and protons were changed, like their charges were changed, the only thing that would change is the direction of the electric field created by charges. Other than that, due to the repulsive nature of the same signs charges and attractive nature of different charges, the behavior of point charges would remain the same, and the same would go for our experiment. And the second question as to why is it important to handle the charge tapes as little as possible, this is because when we touch the charges, some of the excess of electrons get attached to our neutrally charged hands, and then they can alter our results.